Hi guys, this is Miss Goal. Today's lesson is Module 2, Lesson 14, Solving Equations Using Algebra. Your outcomes for today are students will transition from solving equations using tape diagrams to solving equations algebraically by making 0, which is using the additive inverse, and making 1, which is using the multiplicative inverse. Students use algebra to solve equations of the form px plus q equals r and p times the result of adding x and q equals r, where p, q, and r are specific rational numbers, using techniques of making 0, which is the additive inverse, and making 1, which again is multiplying by the multiplicative inverse to solve for the variable. Students identify and compare the sequence of operations used to find the solution to find an equation algebraically. With the sequence of operations used to solve the equation with tape diagrams, they recognize the steps as being the same. Example 1 is a word problem that is going to have us go through a series of questions, and these really should be the questions that you would approach any type of word problem having to do with geometry. Yoshiro has a new puppy. She decides to create an enclosure for her puppy in her backyard. The enclosure is in the shape of a hexagon, which is a 6-sided polygon, with one pair of opposite sides running the same distance along the length of 2 parallel flower beds. There are 2 boundaries at one end of the flower beds that are 10 feet and 12 feet respectively, and the other end, the 2 boundaries are 15 feet and 20 feet respectively. If the perimeter of the enclosure is 137 feet, what is the length of each side that runs along the flower bed? The first thing I want to do is sketch a scenario of this picture, and that's what question 1 asks us to do. What is the general shape of the puppy yard? Draw a sketch of the puppy yard. So we know that it has to be a hexagon, and one of the big elements that they told us was we have a pair of sides running the same distance along the length of 2 parallel flower beds. What that really tells me is that my problem is going to have 2 parallel lines that are the same length. Then we have 2 sides that connect it. Remember, a hexagon will have 6 sides, so we have 2 so far. Here's 3, 4, 5, and 6. And notice I didn't make them all the same length because they actually told us that there are different lengths within those. So at one end of the flower bed, the lengths are 10 feet and 12 feet, and at the other end, they're 15 feet and 20 feet. So we have 15, maybe this is 20, that would make this 10, and this one 12. And then what we do know about the 2 parallel lines is that they are the same length, so we could call this our unknown x, and this is also our unknown x. So having this picture will really help me to understand the scenario. Question 3 says, model and solve this equation with a tape diagram. We were told in this problem that the perimeter of the enclosure is 137 feet. So I know that perimeter means to add up all the sides. So here I'm going to add up all of our elements and make it in a bar model. And I know that all of the sides add up to 137 feet because that's the perimeter. So this entire bar is worth 137. So if I want to solve this bar model, what I would want to do is to put my x's together, so we're combining like terms with our x's, and put our constants together, so we're combining like terms with our constants. So if I add together 20, 15, 10, and 12, I end up with 57. So my new bar will look like this. So if I know the whole bar is 137, I can isolate this section of the bar by taking 137 and subtracting 57. And that leaves me with 80. So what I'm left here with is we have 2 x's equal 80, so if we divide that by 2, we will get the value for a single x. So we have 80 divided by 2 leaves us with a value of 40. And so this tells us that the length of each of the parallel sides was 40 feet. Question 4 says use algebra to solve this equation. So the first thing we had here was 15 plus 20 plus x plus 10 plus 12 plus x is equal to a value of 137. The next thing that we did was we combined our like terms. So we grouped our x's together and all of our constants together. So when I group the x's together, x plus x will give us 2x. And when I add up all the constants, we get a total of 57. Notice the next thing I did was I isolated the x's by subtracting 57 from the value of the bar. So if I'm going to subtract 57 from the bar, that meant I had to subtract it from 137. So these cancel because these are additive inverses of each other, leaving us with 2x is equal to 80. And then notice here that we divided 80 by 2 because there were two x's. So what I'm doing here is dividing both sides by 2, giving us x equals 40 feet. So notice we came up with the same answer as we did using the bar model. And a lot of the steps that we did in the bar model process reflect what happens when you turn it into algebra. Part 5. This is really an important question that a lot of people forget to do. It's reflecting on your answer and seeing if it makes sense in the context of the problem. So if we had gotten an answer that was something like 150 for x, well, if you just add up the two x's, 150 and 150 is 300, but our total perimeter is only 137. So you have to really reflect on your answer and see if it's a reasonable answer. And you can even check in most cases. So here, we can check our answer by adding up all of the sides that we now know. So if we add up 40 plus 40 plus 15 plus 20 plus 12 and plus 10, that gives us a total of 137. So does it make sense in the context of the problem? Yes. Because all sides add up to 137 feet. Let's take a look at example 2. Jenny is on the local swim team for the summer and has swim practice 4 days per week. The schedule is the same each day. The team swims in the morning and then again for 2 hours in the evening. If she swims 12 hours per week, how long does she swim each morning? So the first question I want to answer is write an algebraic equation to model this problem and also draw a tape diagram to model this problem. So she practices each day for an unknown amount in the morning. So why don't we first let x equal the morning swim. So we know that she practices X amount of hours in the morning and then again in the evening for 2 hours. And it tells us that she swims 12 hours per week and practices 4 days per week. So this tells me that this represents 1 day. So if I wanted to represent 4 days, we would multiply this result by 4. And it is equivalent to the total number of hours she swims per week, which is 12. Now for a tape diagram, we could have a value that is unknown, x, and her 2 hours that she swims in the morning. Now notice this represents 1 day, so we would want to replicate these. There's 2 days, 3 days, and 4 days. And the total value of this bar would be 12 hours. Again, we're still learning how to do things algebraically, so why don't we go through and solve this using the tape diagram. Here, I would want to rearrange my tape diagram, putting my like terms together. So I would have 1, 2, 3, 4 x's, and 4 2's. So again, if the whole bar equals 12, we know that these put together, 2, 4, 6, 8, have a value of 8, and so that can help us to solve for the x's. So if I know the whole thing is 12, I would do 12 minus 8 to leave us with 4. So these x's have a value of 4. So if I have 4 x's, I would then want to divide by 4. And that tells us that each one of the x's represents 1 hour. So she swims 1 hour in the morning. Now let's go through and solve this algebraically. So we have 4 times x plus 2. Now in this case, I don't have combined like terms because notice, if I go through and do PEMDAS, which means we're going to simplify as much as possible. P stands for parentheses. I can't combine x and 2 because they're not like terms. I don't have any e exponents in my problem. So the next thing I'm going to look for is multiplication. What I notice is I have multiplication here. We're multiplying 4 by distributing to the x and the 2. So 4 times x will give me 4x, and 4 times 2 will give me 8. The next thing that we did was we isolated the x's by subtracting 8 from 12. And so if I do it to one side, I have to do it to the other because one represents the total amount of the bar and the other one represents the bar itself. So I subtract these, they're additive inverses of each other, so they cancel and we're left with 4x equals 4. And then what we did was we divided by 4 to isolate the x by itself. 4 divided by 4 is 1 because that is the multiplicative inverse. So we're left with x on this side. 4 divided by 4 is 1. Again, that is the multiplicative inverse, so it's 1. Question 3 says, does your solution make sense in the context? Why? Okay, so if we go through and plug in what we now know, we have 4 times 1 plus 2. So if I do PEMDAS on this, order of operations, parentheses, I can add 1 and 2 now. That will give me 4 times 3, and then I have multiplication. 4 times 3 gives me 12, so that checks out. So, yes, because 4 times 1 plus 2 equals 12. So let's just take a moment to look at the 2 examples that we've done so far and focus on solving algebraically and think about what our process is going to be. So if we look back at example 1, we can see that our process first involved combining like terms. In the second problem, the first thing we did was we did distributive property. Now, if there's a combination of these, what you're actually going to do is follow the order of operations, and that's PEMDAS. So P stands for parentheses, E stands for exponents, M is going to be combined with D because multiplication and division is done left to right in the order of operations. And A and S are also going to be combined because addition and subtraction are also going to be combined and done left to right. What I'd like you to add on the end of this is something new. We're going to put an O. And this O will come along with an arrow because O is going to stand for opposite. The arrow meaning we're going to start on this end of PEMDAS and work our way back. So we're going to always take care of addition and subtraction first by doing the opposite operation. Then we're going to do multiplication and division by again doing the opposite operation. And as we go along into high school, you will start to come across problems that do have exponents and maybe even parentheses. So take a look at the fact that we did actually follow this. So here in this problem, we didn't have anything to do in the parentheses. I did though have multiplication. So here we multiplied, and I multiplied into both by using the distributive property, giving us 4x plus 8 equals 12. The next thing I did was the O, because we simplified as much as I could. I can't combine 4x and 8, they're not like terms, so there's no addition or subtraction here. So I move right into the O, and we go backwards. The first thing I come across is addition and subtraction. Well, here we have a plus 8, and so I'm going to do the opposite operation, which is subtraction. So I subtracted from both sides of my equation to keep the balance. Whatever I do to one side, I always have to do to the other side. Once we did that, we were left with 4x equals 4. So then I look through PEMDAS, and the next thing I come across moving this way is multiplication and division. So here we have multiplication between the 4 and the x. So we did the opposite operation, which was to divide, and that got our x by itself. Really what we're using here is the additive inverse here to get 0. That leaves us with our x's. And then when we have just an x, what we're using is the multiplicative inverse, which is essentially multiplying by 1/4 in this case, but we also know that as dividing by 4. Notice example 1 also followed PEMDAS. As I go through, there's no parentheses, there's no exponents, there is no multiplication, but what we do have is addition and subtraction. So I was able to combine like terms and get 2x plus 57 equals 137. From there, we're working with the O elements, and the first thing we come across is addition and subtraction. I happen to have addition, so I subtracted from both sides, left us with 2x equals 80. Then I have multiplication, so I divided both sides by 2, getting us x equals 40. In this lesson, you have learned that we work backwards to solve an algebraic equation. For example, to find the value of the variable in the equation 6x minus 8 equals 40, we're going to use the addition property of equality to add the opposite of negative 8 to each side of the equation to arrive at 6x minus 8 plus 8 equals 40 plus 8. Then we use the additive inverse property to show that negative 8 plus 8 equals 0, so 6x plus 0 equals 48. Next, we use the additive identity property to arrive at 6x equals 48. Then the multiplication property of equality is used to multiply both sides of the equation by 1/6 to get 1/6 times 6x equals 1/6 times 48. We looked at this a little bit differently and just said it was division, but multiplying by 1/6 is the same as dividing by the number 6. Then use the multiplicative inverse property to show that 1/6 times 6 equals 1, and so 1 times x equals 8. Then we use the multiplicative identity property to arrive at x equals 8.